everyone. Welcome to Calculus 3. Today's topic it is in section 2.7, cylindrical coordinates and spherical coordinates. First, let's take a quick look what is cylindrical coordinates. I say if you know polar coordinates very well, hopefully it's just easier to understand the cylindrical coordinates. Cylindrical coordinates, it is simply the extension of polar coordinates to the three-dimensional space. So accordingly, we use notation and order the triple r, theta, and z to denote the cylindrical coordinates. And then let's take a look what's the actual meaning of cylindrical coordinates. I do have a graph over here. Okay, we know in the three-dimensional space, a point is an ordered triple. And now with cylindrical coordinates, we are having r, theta, and z. R, it is the distance of the point projected to the xy plane, and then the distance in the xy plane, that is r. And the theta, it is the angle from the x axis to this r. This is r, the cylindrical coordinates. And then if you wonder how do we make the conversion, now we know a point is an ordered triple, and the ordered triple could be in the fashion of x, y, z, that's for the rectangular coordinates, or could be in the fashion of r, theta, z. It doesn't matter which fashion, it will have to represent a same point. So how do we make the conversion? So this is the formula, the conversion between cylindrical and rectangular. The Cartesian coordinates, I think it's just the rectangular coordinates. Okay, so x is r times cosine theta, y is r times sine theta, and indeed there is no change for the z coordinate. You see, in the cylindrical and Cartesian coordinates, z stays the same, so no worry about z. And then if you know the rectangular, you want to figure out the polar coordinates. And I say it would be a lot easier if you look at the chart here. R is the hypotenuse of the right triangle, right? So R, accordingly, it is the square root of x squared plus y squared. Tangent theta, it is, remember the phrase SOHCAHTOA, tangent, it is the opposite over the adjacent. So tangent, it is y over x. We'll talk about this tangent theta a little more because this formula does not give out the angle directly. It takes a little extra work to figure out the angle. And we'll talk about that case in a moment. Okay. So this is the topic for the conversion between cylindrical and the rectangular or the Cartesian coordinates. How about let's look at one example here. Okay, I just took the example from the textbook, convert from the cylindrical to the Cartesian or rectangular coordinates. Basically, there's no surprise in this part. And we are going to use the formula x is r times cosine theta. So r is given as 5. Theta is pi over 6. And also you need to know those triangles or the trigonometric function values for some special angles precisely, exactly. So cosine pi over 6, I believe that's a square root of 3 over 2. R times cosine theta, 5 times cosine pi over 6. I got this number over here. Then y is r times sine theta. And r is 5. Sine pi over 6, that's 1/2. So I get 5 over 2 here. And the z coordinate really stays the same. But anyway, for completeness sake, I'm still putting here. Okay, the rectangular coordinates are 5 times square root of 3 over 2, 5 over 2, and 4. From cylindrical to the rectangular coordinates. Next one, it is the other direction. Hopefully, we will see some insight why, how do we handle the angle theta. So checkpoint 2.56, it is the conversion from rectangular to the cylindrical. And I still basically pretty much I just copy the formula from here. R is square root of x squared plus y squared. So I did that. And also tangent theta. Tangent theta, it's y over x. But anyway, it is -1, right? 8 over negative x is -1. Z coordinate still stay the same. Don't worry about z coordinate. Still, the thing is, still want you to know, we're not done yet. Converting from rectangular to cylindrical, we need to tell the theta precisely. I hope you remember we have many choices because trigonometric function, even tangent theta, it's a periodic function. It's a periodic function. We do have many choices for this tangent theta equals -1. So I think I have a very rough sketch here. Okay, this would fit for the case when we have tan x and y, x is negative, y is positive. So I'm seeing in the xy plane, that is a point in the second quadrant. And then I did some very rough drawing here. I figured out that the angle got to be in the second quadrant. And indeed, because of 1, I hope you know, tangent of pi over 4 is 1. Certainly it is related to pi over 4, but the answer is 3 pi over 4 because we are having tangent as a -1. And also, I think the other example I just want to mention here is that, well, in the case, what would happen in the case if we are considering the rectangular coordinates in this fashion? 8, -8, and I try to keep the z coordinate the same. So if we are having 8 and -8, I hope you see, according to the conversion formula, tangent, it is still -1. But according to my drawing, this time the point I'm having here in the xy plane, it is in the 4th quadrant, right? So accordingly, you're not going to say the angle is 3 pi over 4 in this shape. I'm seeing the angle that's -pi over 4. Okay. So you really want to be very careful, especially if you are considering from rectangular to cylindrical. It is about the angle. It is about the angle. In the formula given, it is for tangent theta. Then to find out the actual theta, I think it is a good idea. You want to plot x and y as a point in the xy plane, in the two-dimensional plane. And then hopefully you can observe how the angle would look like in the two-dimensional plane, how the angle theta would look like. Okay, so I think this is it about conversion between cylindrical and rectangular coordinates. Thank you for watching.